Hi, everyone. This is lesson 5.1, which is the beginning of our unit 4. So for many of you, this will be review. I'm actually reusing a lesson that I have taught my intermediate algebra class, Math 0931. Some of you have taken that class, some of you haven't. So anyway, just do your best. You might be able to fast forward through parts of this or skip parts that you've seen before, or you might benefit from watching the whole thing. And when we're in class together, we will do lesson 5.2, which will be systems of equations in 3 variables. So using the same concepts that we're using with 2 variables, but it's going to be a little harder and a little more challenging. So here we go. So lesson 5.1, systems of equations. There's 3 methods for solving systems of equations. First of all, a system of equations is when you have more than one equation. So as we're looking at the screen here, you can see 2 equations and there's 2 variables. That's what we're going to focus on in this section. In the next lesson, when we're in class together, we will look at systems that have 3 equations with 3 variables. We'll also eventually see systems that have non-linear equations, meaning the degrees of those will be higher than 1. For this lesson, though, our equations will have a degree of 1, meaning only exponents of 1, meaning you won't see any exponents. So the 2 methods we're going to be focusing on are called substitution and the addition method, sometimes called elimination. However, there is another method that you may have learned before, which is solving by graphing. So just to kind of remind you about that, you could take your 2 equations and graph them as lines using y equals mx plus b, or slope-intercept form. You could graph your 2 equations as lines and observe where they intersect each other. That's not the approach we're going to focus on in our class, but you may have learned that before. So here's a quick example. X plus y equals 5 and y equals 2x minus 4. If you take the first equation that's in blue here, x plus y equals 5, if you subtract x on both sides, you would get y equals negative x plus 5. And then you could graph that line starting at 5 on the y-axis and then using a slope of -1 going down 1 over 1. For the red one, y equals 2x minus 4, the y-intercept would be -4 or 0, -4 on the y-axis. And then you could use a slope of +2 and go up to over 1. So the next slide, I believe we'll see this system graphed, and we'll see some other systems that are also graphed. And this will be a nice little introduction to what could happen when you solve a system of equations. Sometimes there's a solution, sometimes there's not. So let's take a look at that. Here's our next slide. Okay, so the first graph that you're seeing on the left here, this is the most common scenario where you have 2 lines that cross each other at one single point, which I'm highlighting right now in yellow. So if you're looking at 2 lines intersecting each other at one point, that one point is your solution. So this is the most common scenario where you have exactly one solution to your system of equations. So in this example, the lines cross each other at 3, 2, which means x is 3 and y is 2. That would be the solution to that system. Okay, here's some other scenarios that can happen. These are a little less common. In the middle here, if you have 2 equations, and when you graph them, they are lines that are parallel to each other, they never cross. And so in that situation, you would have no solution. We're going to see what that looks like algebraically a little bit later. When you solve systems, there will be a way to tell that there's no solution without needing a graph to look at. But just for now, just taking a look, notice that these 2 lines both have a slope of 3. But they have different y-intercepts. So they're both going up 3 over 1, which means they're never going to intersect each other. They're just always going in the same direction, parallel to each other. So this would be an example where there's no solution. And then this third example, this one's even less common. Sometimes your 2 equations will actually turn out to be the same equation. So if you look carefully at these 2, x plus 2y equals 4, 2x plus 4y equals 8. If you were to take that second equation and just divide both sides of the equal sign by 2, you would get back to the original equation written right above it. Those 2 equations are actually not 2 different equations. They're the same. So if you were to graph both of these equations as two lines, it wouldn't be two lines, it would be one line. So this situation is kind of strange where instead of having two lines crossing at one point, it's two lines that are the same. So they're crossing at all the points. So they don't just have one solution, there could be infinitely many solutions. So we'll see what that looks like algebraically. How are you supposed to know if there's infinitely many solutions without a graph to observe? We'll get to that in a few minutes. So these are the three types of scenarios you can have solving a system of equations. You can have one solution, no solution, or infinitely many solutions.